Welcome to the new topic, decimal to octal conversion. In this case, we will do continuous divisions and multiplications by 8 as that is given below. Suppose we are having the number 23.46 written with base 10, that is decimal number, and we want to convert this number with its equivalent representation in octal form, that is with base 8. Okay, so in this case we have to do continuous divisions by 8 for this part, whereas we have to do continuous multiplications for this part. Okay, now look at how we have to perform this. That is 23, we have to divide it by 8 and write down the remainder at this position. Okay, then 23 divided by 8 is 8 to the 16 with remainder 7. Then again divided by 8, quotient 0, remainder 2. So this will be your MSB and this will be your LSB. Now partially writing the result, that is 27 point. Please note down, we are not writing here the decimal part. Now for decimal part we have to continuously multiply this factor and the result with 8. 8 6 are 48, 8 4 are 32 plus 4 6, that is 36. Okay, so we have to write this 3 at this location, that is as 3. Now again we have to multiply 68.0.68 with 8. 8 8 is 64, 8 6 is 48 plus 6, 54. Okay, it means this we have to write this 4 at this position like this, that is 5, and then multiply 0.44 with 8. 8 4 is 32, 8 4 is 32 plus 3, that is 35, and we have to write this 3 at this location. 3 and then again multiply it with 0.52, then 8 to the 16, 8 5 to 40 plus 1, 41. Okay, then we have to write, you can stop here up to 4 positions, it is sufficient. So you can say that this is the approximate result of conversion of 23.46 in decimal. Okay,
now we will do octal to decimal conversion. In case of octal to decimal conversion, we have to multiply each digit either by positive powers of 8 or by negative powers of 8. Okay. So, take an example. In this case, suppose we want to convert this 27.365 by 8, that is with base 8 in decimal number. Okay, we want this expression. Then in this case, for this side we have to multiply 8 digit by powers of 8, positive powers of 8, whereas we have to multiply this side with negative powers of 8. Okay. So, in this way, if we do it, then for this value we have, that is, we have to write it like this, that is 2 multiply 8 raised to power 1 plus 7 multiply 8 raised to power 0 plus 3 multiply 8 raised to power minus 1 plus 6 multiply 8 raised to power minus 2 plus 5 multiply 8 raised to power minus 3, and this will be the equivalent value in this decimal value, decimal number. So, this is 8 to the 16 plus 7 plus 3 by 8 plus 6 by 64 plus 5 by 6 8 raised to power 3. Okay. And we have to solve it and we will get the answer. Okay. Final answer you can get it from this. Now, if we want to convert this number 27.365 in its equivalent binary number, then it is very easy here. Okay. Just we have to write this 7, 2, 3, 6, 5 in 3-bit representation, 3-bit binary representation like this, as 2 is equals to 0, 0, 1, 0, 7 is equals to 1, 1, 1, 3 is equals to 0, 1, 1, 6 is equals to 1, 1, 0, 5 is equals to 1, 0, 1. So, we have to write here 0, 1, 0, comma 1, 1, 1, point 0, 1, 1, comma 1, 1, 0, comma 1, 0, 1, and it is the equivalent representation in binary form. That is, we can also convert this number in binary. Now, what about if we want to convert a binary number to octal? Okay. In this case, we have to make group of 3. Just remember that, make group of 3 bits. Okay. Now, for the left hand side of the decimal, we have to start from this position, and from right hand side of the decimal, we have to start from this decimal, and if we left behind uncompleted group, just assume there is a 0. Suppose we have a number, for example, we want to convert 1 0 1 1 1 0 1 1 1 1 0 1 1 point 1 1 0 10111, okay, and we want to convert it into its equivalent octal number. Then just make pairs. First pair is this one, second pair is this one, third pair is this one, pair of three group of 3 bits, 4 is this one, and here we left only 1. So, we can assume here 0 0. So, this forms another group. So, this is equivalent 1, this is equivalent 2, sorry 3, 5, 7, 3. Now, for this side we have to make group in this way, that is 6, 5, and we left behind 2 bits. So, we can write 0 here. So, this is 6. So, equivalent value in octal form is 1357.6568. Okay. So, in this way we can convert binary to decimal and decimal to binary, binary to octal and octal to binary, or octal to decimal and decimal to octal. Now, if we want to convert a number in from decimal to hexadecimal, and hexadecimal to binary, or vice versa. Okay. So, in this case, take an example. Suppose we want to convert 136 in binary to its equivalent hexadecimal form. Okay. So, just remember here we have to use 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and after that for 10 we will use A, for 11 we have to use B, for 12 we have to use C, for 13 we have to use D, for 14 we have to use E, for 15 we have to use F. Okay. So, in this way there are 16 possible values, 16 possible digits you can use in hexadecimal. So, for this case we have to divide it by 16.
So, we will get 8 times here, that is 128. Okay. And we will left behind only 8. So, this is quotient. So, in this way we can write it like this, that is 136, 16, remainder is 8, and we get 8 here, then again we divide it by 16, then 0, then this, and this we have to write in this way, that is this is your MSB and this is your LSB. So, we get the number. And oppositely, if we write 88 in its equivalent decimal value, then we have to solve it like this: 8 multiply 16 raised to power 0 plus 8 multiply 16 raised to power 1, and that will gives you, that is 136 in equivalent decimal. Okay. Now, if we want to convert this 8816 in its equivalent binary form, then just we have to write this digit using 4-bit binary. and we have to write this digit also with 4-bit binary. It means we have to write each digit in its equivalent 4-digit binary number. So we will get 1000 comma 1000. Now if we want to convert this number in its equivalent octal form, then just make a pair of 3. This is your 0, this is your 1, and this is your 2. Okay, so in this way we can convert from any number system to the other number system, and it's a very easy task here. Now in general, for this course we use this representation here, that is this is your b2 b3 4-bit number representation I am writing here, that is this is your LSB, this is your MSB, and here its equivalent decimal value. So in this case, if we write this part, then you can see that in decimal we will continue it like this: 1 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, and in this way so here 0 0 0 0. Okay, this is 0 0 0 1, and this is 0 0 1 0 0 0 1 1 0 1 0 0 and 0 1 0 1 0 1 1 0 0 1 0 0, sorry, 1 1 1 0 0 0 1 0 0 1 1 1 0 0, no, 1 0 1 0 1 0 1 1 1 1 0 0 1 1 0 1 1 1 1 0 1 1 1 1. And if we write its equivalent hexadecimal representation, then we get it is 0 1 2 3 4 5 6 7 8 9 A B C D E and F here. And what actually is this? This position represents 2 raised to power 0, this position represents 2 raised to power 1, this position represents 2 raised to power 2, this position represents 2 raised to power 3. So 2 raised to power 0 is equals to 1, 2 raised to power 1 is equals to 2, 2 raised to power 2 is equals to 4, 2 raised to power 3 is equals to 3. So this format is also known as 8421 coding or representation. Okay. So in this way we have to remember at least this part, and look at this, that bit position B0 will change after every step. Okay, it changes after every step, that is 0 to 1, 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to, whereas bit 1 is changing after every 2 steps. Okay, whereas bit 2 is changing after every 4 steps, and in this way where this bit 3 is changing after 8 steps. So that's why is also known as is 8421 representation. Thanks for watching this video.